Hello AP Statistics students. In this video, we're moving on, all right? This is an intro to the next chapter, chapter 8. We're gonna first start by identifying what are called point estimators. That's just a fancy new vocabulary word for something we already kind of know. Then we're gonna introduce a new idea, the idea of the confidence interval, all right? Which describes an interval of plausible values for an unknown parameter. So that's what we're building towards, and hopefully by the end of this video that will all make sense. So first, what is a point estimator? All right, so nothing crazy here. You may have even seen this word a bit in the textbook or somewhere. A point estimator is simply a statistic, all right? A single statistic from a sample, okay, that we use to estimate a population parameter. So with this chapter, we're going to acknowledge the fact that in reality, oftentimes we don't know a population parameter. We just know the statistic. In our previous unit, when we were studying sampling distributions, we oftentimes knew the population parameter. But most of the time you don't know a population parameter. That's why you're taking a sample in the first place. You want to know something about the population parameter. And so all you really have to go on oftentimes is a point estimator. So let's take a look at the ramifications of this a little bit, all right? So first, the idea of a confidence interval. So Mr. Bolt has a giant container of beads. He knows the true proportion of red beads in the container, but he isn't telling. You take a sample of 200 beads and find that 60, or 30% of them are red. Is this the population proportion of red beads? Hopefully you see that no, that's not the actual population proportion, right? It's not going to be exactly 30%. Sampling variability. All right, so the population proportion will not be exactly 30% because of sampling variability. This is a point estimate. Okay, 30% is our point estimate. It's our statistic. We know it's not perfect, but it's all we've got because Bolt is not telling the actual proportion of red beads. So what do we do with that? Well, this is our idea. So a clever student says we should make a range of values where the true proportion could be by adding and subtracting a little bit from our point estimator. That's the idea of a confidence interval, okay? You don't know the exact population proportion. You only have a point estimate. So instead of just going with your point estimate 30%, you make a range of values, all right? An interval from blank to blank. And you say, hey, I'm pretty sure that is where the true proportion is. That is a confidence interval. You've probably heard something like this on TV when we report polling results. They'll often say 52% of voters support this with a margin of error of plus or minus blank. That is a confidence interval. Okay, we're going to take a look at what that means and how to make one and how to interpret one now. So let's say I'm still on the beads, okay? We're still looking at the beads. Let's say we create a sampling distribution for the proportion of red beads for p hat, okay? So remember, p hat is the proportion for a sample, so it's a proportion for a sample of 200 beads, right? And if I build the sampling distribution, I know the center of the sampling distribution is the true population, right? The true population proportion is the center, all right? The average of all the p-hats is the actual population proportion p. Those are the same thing. The problem is my 30%, right? I got 30%. I don't know where that goes. I mean, it could be a little above the population proportion. It could be a little below. There is a chance that it's way down here. There's a chance that it's way up here. I don't know where it actually falls. So what can I do? Well, we have this idea. I do know that this distribution is normal. Okay, assuming n times p is greater than 10 and n times q is greater than 10, but with a sample size of 200, I think I'm pretty safe. Okay, well, because this is normal, I know this. 95% of all sample proportions are within 2 standard deviations of the true population proportion. Oops, I forgot my n. Right? We know the 68, 95, 99, 7 rule, right? 95% of all samples will be between here and here. That's just the basis of the normal model. Well, that means I am 95% sure my sample is within 2 standard deviations of the true population proportion. All right, I might recommend copying, pasting these. These are kind of big statements that I want you to understand. All right, if 95% of all samples are within 2 standard deviations, so from there to there, 95% of samples are there, then I'm 95% sure that my sample is between there and there. I'm hoping that kind of makes sense. One more logical leap here. Well, if I'm 95% sure that my sample is within 2 standard deviations of the true population proportion, I am 95% sure the true proportion is within 2 standard deviations of my sample proportion. So yeah, I just flipped that sentence around, all right? If you are standing 2 feet away from me, I am standing 2 feet away from you. I'm just sort of flipping that logic around. If I'm 95% sure my sample is within 2 standard deviations of the true proportion, I am 95% sure the true proportion is within 2 standard deviations of me. All right, so again, what I'm doing here, I don't know where to put my dot for 30%. But I am 95% sure, all right, this is my 2 standard deviation ruler. I made it pretty much exactly 2 standard deviations wide. I am 95% sure it is within that range above and that range below. So what I'm going to do here is I'm going to think of my dot. Here's my dot. I don't know where to put it, so I'm going to put it here. This is my p-hat. I am 95% sure that the true proportion will be somewhere in the range of 2 standard deviations above my observed value, or 2 standard deviations below my observed value. Okay? So, like, one option could be if I say my dot is right here. Okay? Well, that is within 2 standard deviations of the middle. I'm going to take my ruler. As you can see, the true population proportion is inside that ruler. There's a 95% chance of something happening like that. Now, it could be way over here, too. If I put my ruler right there, I'm still within the 2 standard deviation ruler of the middle. All right, that will happen 95% of the time. And so this idea right here is going to become my confidence interval. I'm going to take my observed proportion, and I'm going to add some to it, and I'm going to subtract some to it. Now, in this case, because I was doing 2 standard deviations, I am 95% sure. If I wanted to be 99.7% sure, I would have to go out 1 more standard deviation, wouldn't I? The ruler would get bigger. My interval would get bigger. But I would be 99.7% sure then. All right, that's the idea of a confidence interval. Now, I'm not worried about calculating it quite yet. Right now, we are just interpreting it and kind of getting a feel for what it is. The calculations will come later. But this 3-step logical progression right here is pretty important. Okay? If 95% of all samples are within 2 standard deviations of the true proportion, I am 95% sure that my sample is within 2 standard deviations. Then that means I'm 95% sure the true proportion is within 2 standard deviations of my proportion from the sample. Okay? All right, so let's put some definitions down. What is a confidence interval? A confidence interval is an interval of plausible values for a population parameter. We're going to start with proportions, but we are going to do means as well. So I'm just going to say a population parameter based off a point estimate. All right, a confidence level. This is how sure you are that the true proportion, is inside your confidence interval. Okay? How sure are you that the true proportion is inside your confidence interval? All right. Interpreting a confidence interval. Yes, you got to write a sentence. All right. So the sentence frame you are going to want to be able to replicate is, we are blank % confident. You can use the word sure also. All right. We are blank % confident the interval of blank to blank captures the true, not proportion, it could be any parameter, the true, and then whatever parameter you are looking at. Make sure you, of course, add context. Okay? We are blank % confident or sure that the interval from blank to blank captures, I should probably have an S, shouldn't it? Captures the true parameter. So the margin of error, this is just another way of thinking about the confidence interval. So instead of an interval, this is the distance at most we believe the true proportion could be from. All right, how far, at most, do we think the true proportion could be from our point estimate at a certain confidence level? So to give you a visual of that, I'm going to redraw a picture I already had. So let's say we have our point estimate right here, p hat. Okay. Depending on our confidence level, we're going to add some standard deviations. And then we're going to subtract some standard deviations, right? Now, that gives us an interval from here to here. That's the confidence interval. The margin of error is how much you add and subtract. And the margin of error is what you'll often find if you see a statistic reported on the news. They'll say, hey, 52% of voters believe this, with a margin of error of plus or minus blank. Oftentimes we report it that way. It's just what are you adding and what are you subtracting from your point estimate. But that gives you an interval. So they are very much the same thing, or reporting the same information. All right, let's look at an example. What do I want you to be able to do right now with this information? Okay. So 2 weeks before a president election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the 95% confidence interval for the population proportion who favor candidate A is right here, between 48 and 54%. So what I want you to be able to do right now first is interpret that confidence interval. All right, so what does that confidence interval mean? It means we are 95% confident. All right, we're 95% sure the interval from 48%, you can do a decimal or a percentage, to 54% captures the true proportion, context time, right? The true proportion of, all right, what's our parameter? Registered voters who favor candidate A. All right, so I took that context straight from the problem, right? We looked at the ones that were favoring candidate A. We were only looking at registered voters, not everyone in the United States, just registered. We're not calling up 5-year-olds right now, okay? So that's the sentence I want you to be able to write. We are 95% sure that the true proportion, whatever it is, we don't know, is between 48% and 54%. All right, next. What is the point estimate that was used to create the interval? And then what is the margin of error? All right, so we have the interval from 0.48 to 0.54. What was the actual point estimate? So again, in my mind, I think of the picture. Here's our point estimate. Our interval goes up from that, and it goes down from that. And our interval was 0.48 to 0.54, right? So this is in, I know my drawing's bad, but this is the middle. What's the middle of 0.48 and 0.54? Now, this one you can do in your head, 0.51, right? It's 3 down, 3 up. But if you can't do that in your head, you would just take 0.48 plus 0.54 and divide it by 2. All right, it's like you find the middle of your test scores, you average them, you can average the top and the bottom to find the middle. But oftentimes you can just do that in your head. Where's the middle? So our point estimate was 0.51, which means when we did our sample reported out a proportion of 51%. Okay, but we knew that wasn't exact, so we made the interval. And our margin of error was plus or minus. How much did we add? How much did we subtract? Again, you can do this in your head, I'm hoping. But you simply have to see we were adding 3% and we were subtracting 3%, right? So it was plus or minus 0.03. All right, and the last one. Based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. A common mistake. Okay? Well, look, the confidence interval is well above 50%. Oftentimes, but not all the time. The point estimate was above 50%. But remember, a confidence interval describes the plausible values of the true proportion. And because this plausible value goes below 50%, 50% is a plausible value. So it could be 50-50. That's a plausible value. So we don't have any evidence to claim that the majority of registered voters favor candidate A. Because 50-50 is a completely plausible value in our confidence interval. Okay, we can't say one is more likely than the other. All right, we don't have anything like that. We don't know where 0.51 is in our sampling distribution. So if 50-50 is just as plausible as all the others, we do not have evidence that the majority of voters favor candidate A. Because 50% is inside our confidence interval and is just as plausible as any other value in the interval. Okay, it's just as plausible as 48, as 54. So we do not have evidence that they favor candidate A, because 50% is inside our interval. All right, now if you're thinking, well, how do I make one of these intervals? Good question. Stay tuned. Next week we will work on that. For now, this is all I'd like you to be able to do. All right, write the sentence for a confidence interval. With a confidence interval, find the point estimate and then the margin of error, how much you're adding, how much you're subtracting, and then make some fairly simple justifications based off of that confidence interval.